Welcome to Thuma Mina Teaching. Let's have a look where we are at in the curriculum. We will be covering the topic congruence. So have a pen and book at hand and take some notes. When we say that two shapes are congruent, we mean that they are identical. They are exactly the same. They are the same shape and the same size. We indicate congruence by using this symbol, these three horizontal lines. If we have three vertical lines, we say that they are similar. Let's look at these two triangles, triangle ABC and triangle DEF. You may move, rotate, or flip the shapes to fit each other. If you do that and they fit exactly onto each other, we say that they are congruent. Triangle ABC is congruent to triangle DEF. That means that their corresponding angles and corresponding sides are equal. It is very important for you to say the word corresponding angles or corresponding sides. If we say that the angles are equal and the sides are equal, that is not true, as not all of the angles and the sides are equal. Corresponding means that this angle is as large as this angle, and that this side is equal to its corresponding side, that side. The order in which we name the triangles are very important. Over here I see that triangle ABC is congruent to triangle DEF. Since the symbol is written between the two triangles, then that means the angle written first is exactly the same size as the angle written first in the second triangle. If the angle B is written in the middle, then that means it's exactly the same size as angle E written in the middle. If angle C is written last and it's congruent to triangle DEF, then angle C and angle F will be the same size. Therefore, A is equal to D, B is equal to E, and C is equal to F. It also tells me something about the sides. AB, which is written first and second, will be the same length as DE, which is also written first and second. Also, B and C, which is written second and last, will be the same length as E and F, which is also written second and last. Side AC will be the same length as side DF, as it's written first and last. Therefore, the order is extremely important. So if the corresponding angles and the corresponding sides are equal, I can say that these two triangles are congruent. So what if we didn't say triangle ABC from the beginning? What if I said triangle BCA? What if I want to say that triangle BCA is congruent to the other triangle? That is perfectly fine as long as the same corresponding angles are in the correct order. Therefore, I know that angle E is the same size as angle B. And since B is written first, I am going to write E first. I also know that angle C and angle F are the same sizes. So if angle C is written in the middle, angle F must be written in the middle. I also know that angle A and D are the same sizes. So if A is written last, then D must be written last. The same goes for if I want to say triangle CBA. If I want to say triangle CBA is congruent to the other triangle, once again the order matters. Since angle C and F is the same size and C is written first, F must be written first. B is in the middle and the same size as E, so E must be in the middle. A is written last and the same size as D, therefore D must also be written last. Now let's have a look at the 4 cases of congruence. You can only prove that two triangles are congruent if you make use of one of these 4 cases. Our first case is side, side, side. That means that I need to have 3 corresponding sides. The one side of the one triangle must be equal to a corresponding side in the other triangle. And that must be true for all 3 sides. Over here, I can see that my one side is equal to its corresponding side. It's clearly indicated that this side is equal to the corresponding side, and the third side is also equal to its corresponding side. Since I have 3 equal corresponding sides, that means that my 2 triangles are congruent. Let's have a look at an example. In triangle ABC and triangle CED. In this case, the order does not matter, as long as my congruence symbol with the 3 horizontal lines are not written between my 2 triangles, the order does not matter. So now I can clearly see side ED is exactly the same length as side AB. So I can write that AB is equal to side ED, which is 30 millimeters, and my reason will be given. I can also see that side EC is the same length as side CB. So I can write that BC is equal to EC, which is 25 millimeters. This is also given. Lastly, I see that my third corresponding sides are also equal, which is AC equal to CD, 19 millimeters. This is also given. Therefore, I can say that triangle ABC is congruent to, and now I need to make sure that my order is correct. So I know that it must be congruent to triangle DEC. To verify myself, I can clearly see on my sketch that it's true that AB is the same length as DE, as well as BC being the same length as EC, as well as AC being the same length as DC. Therefore, I know that my order is correct. But now I still need to give my reason for congruence. And my reason is the fact that I have 3 corresponding sides equal. So I write side, side, side. My second case for congruence is side, angle, angle. That means I need 1 corresponding side and I need 2 corresponding angles. So let's look at this example. Over here, I have one side with a corresponding side being equal, as well as one angle with a corresponding angle being equal, as well as a second angle with a corresponding angle being equal. If this is the case that I have 1 corresponding side being equal and 2 corresponding angles being equal, then it is also true that the triangles are congruent. Let's look at another example. So in triangle CED and triangle ABC. Once again, the order does not matter as long as I don't insert my congruent symbol between my triangles. First of all, I can clearly see that side ED is the same length as side AB. So I write that AB is equal to ED, which is 25 millimeters, and my reason is given. Furthermore, I can see that my 2 lines are parallel. That means I am allowed to see a Z. Now, if I see this Z, it is clear that this angle A would be the same size as angle D, which would make angle D 30 degrees as well. So angle A is equal to angle D, which is 30 degrees, and my reason for that is alternate angles. Remember to always write your parallel lines. So I write alternate angles, and I write that AB is parallel to DE. Furthermore, I know that angle C2 is the same size as angle C1, since they are vertically opposite angles. That would cause C1 to be 40 degrees as well. So I write that angle C1 is equal to angle C2, which is equal to 40 degrees. And my reason is vertically opposite angles. Now I clearly see that I have 1 corresponding side equal. and I have two corresponding angles equal. Therefore, I can say that triangle ABC is congruent to triangle, and now my order once again is extremely important. I indicated that angle A is the same size as angle D. So I need to write A and D on the same place. Since A is written first, I need to write D first. Then I write E and C. Since angle C is the same size as angle C, C1 and C2. So I can test myself to see, is it true that AB is the same length as DE, which it is. I can also see that angle A is the same size as angle D, and angle C is the same size as angle C. So my order definitely is correct. Now I need to give a reason for my congruence, and my reason is side, angle, angle. My third case to prove congruence is side, angle, side. It is very important for you to see that my angle is specifically written between my two pairs of corresponding sides. Therefore, I can see that since this side is equal to its corresponding side, and this angle is equal to the corresponding angle in the other triangle, and this side is also equal to its corresponding side in the other triangle, it's clear that I can prove congruence, side, angle, side, since my angle is between my two sides. Now, before looking at an example of case 3, I first need to show you another property. Over here I have two triangles, but these two triangles share a side. Side BC is a side that is in both triangles. Side BC is in this triangle, but side BC is also in this triangle. Therefore, I call side BC a common side. Now let's use this property as well as case 3 of proving congruence in an example. Over here it is indicated that side PR is the same length as QS. So I can write in triangle PQR and triangle RQS. Once again, the order does not matter as long as my congruence symbol is not written between my two triangles. So I know that PR is the same length as QS, and this was given. Furthermore, I see that my two sides are parallel. So I can see a Z. It is important to note that I may not say angle R now, as when I look at point R, I see that there are two angles at point R. Therefore, if you say angle R, we don't know which angle you are referring to. Therefore, I write that angle PRQ is equal to angle RQS, with it being 30 degrees. And my reason is alternate angles, with my parallel lines PR being parallel to QS. Furthermore, it is clear that RQ is a common side. RQ is a side in this triangle, but it is also a side in this triangle. So I write that QR in the one triangle is equal to QR in the other triangle, and my reason being a common side. I have already proved that angle R is the same size as angle Q. Therefore, angle R and angle Q has to be on the same place when writing the names of the triangle. Now I need to test myself. Is it true that PR is the same length as SQ? Yes, that is true. Is it true that RQ is the same length as QR? That is exactly the same side, so yes it is. Is it true that angle R is exactly the same size as angle Q? Yes it is. So therefore I know that my order is correct. I can write my reason now, which is side, angle, side, since my angle is between my two sides. The fourth case, also the last case of proving congruence, is a right angle, hypotenuse, side. You are also allowed to write 90 degrees, hypotenuse, side. That means I need a right angle in both triangles, That also means I need my hypotenuse in the one triangle to be equal to the hypotenuse in the other triangle. And then the last S is for any side. So any of the sides left has to be equal to a corresponding side in the other triangle. Let's look at this example. I see that this triangle has a 90-degree angle, which is corresponding to the angle in the other triangle, which is also 90 degrees. I see that my hypotenuse in the one triangle is equal to my hypotenuse in the other triangle. So now I just need one more corresponding side to be equal. I see that this side is equal to the corresponding side in the other triangle. Therefore, I have a side which is not the hypotenuse, which is equal. Therefore, I can say that these two triangles are congruent, with this being my reason. Let's look at an example. Show that these two triangles are congruent. First of all, I'm going to write in which two triangles I'm working. In triangle SRV and triangle KVR. Once again, the order does not matter as long as my symbol for congruence is not written between them. I clearly see that they indicated that SR is exactly the same length as RK, so I can write given. I also see that angle SVR is equal to angle KVR, which is 90 degrees, and I can also write that that was given. It is also true that side VR is a side that is in both triangles. Therefore, I can say that this is a common side. So I write that RV of the one triangle is equal to side RV of the other triangle, and my reason is common side. Now I can say, therefore, these two triangles are congruent. So triangle SVR is congruent to triangle KVR. And now I need to write a reason. But before I write my reason, let's first check if we are correct. Is it true that SR is the same length as KR? Yes, that is true. Is it true that angle SVR is the same size as angle KVR? Yes, that's true. Is it true that side VR is equal to side VR? Yes, that's true. So therefore I can say these two triangles are congruent, with my reason being a right angle, a hypotenuse, and another side. I may also say 90 degrees, angle, hypotenuse, side. Here are a few examples on the topic of congruence. Try them yourself. The answers will follow. Goodbye for now. See you next time when we'll be discussing similarity.
We hope you benefited from this video lesson. Our vision at Thuma Mina Teaching is to accelerate access to quality education. And our dream is to see learners across South Africa flourishing academically. We are a non-profit company and we are entirely dependent on public support. We produce lessons at the rate at which they are funded. As soon as a lesson is funded, it is published to the entire growing audience of Thuma Mina Teaching. Please consider taking hands with us in one of the following ways. Share our content with others that can benefit from it. A great way to support us is to find us on My School and to add us as your beneficiary. And consider donating towards a lesson or ask your company's CSI department to partner with us. We are a PBO, so your donation is tax deductible. Our contact details you'll find on our website www.tmteaching.co.za. If you want to reach out to us, please email us on admin@tmteaching.co.za.